In section 2, let's look at some of the design considerations that are important when developing cloud applications. One important thing to notice is that the cloud brings a completely new environment that is very different from the web itself, although it is running on top of the web. But as a platform for software development, it is a completely new environment. Of course, we could still call cloud applications web applications because the cloud is on the web anyway. So it is important to notice that there is a need to introduce new considerations to the traditional web application design methods and approaches. We can't just take the web application design approaches and methods the way they are and just use them for cloud applications. There are huge differences between the web as an application environment and the cloud as an application environment. Although the cloud is actually running on top of the web, or if is even accessible via the web, but it brings in a different development environment. So let's start by looking at the first consideration, which is scalability. Right. Normally, the cloud brings in a very important benefit, and this is dynamic scaling, the ability to dynamically reconfigure itself, either increasing resources or and so on. So scalability is the major reason why most organizations are creating cloud applications. That flexibility, with the ability to grow automatically without purchasing new hardware, new resources, is a big advantage, and it's a factor that pulls the crowd to the cloud. So considerations that help achieve dynamic scalability include concepts that we have already known in software engineering. For instance, loose coupling of components is a desirable property when you design software, and this is very important in cloud applications. The reason is that if components are loosely coupled, it is then possible to scale each component independently, especially if you determine that that particular component causes bottlenecks. It is possible to actually increase it in size and have a target so that the cloud can automatically scale it when demand increases. The next aspect is asynchronous communication between components. This is a desirable property for cloud applications, and it's possible to add capacity by adding additional servers when the cloud load increases. Of course, when you have loose coupling, of course, there is this assumption that the components need to be able to communicate with each other, but the rate of communication need to be unrelated to the rate at which the other module can consume the output. In other words, if your two modules are connected such that the output one is input to the other, the rate of acceptance of input by the other module should not really slow down or even break down the previous module. So we need you need to have asynchronous communication such that it is possible to take out one module without affecting the functioning of the other module. Then second consideration, of course, or rather that aids in dynamic scalability, is stateless design. This is where state is stored outside components, allowing scaling apps independently. Of course, this concept is quite important. In other words, the state, any information is stored outside a particular module, a particular component, which basically means it shouldn't matter whether it is switched off or on. It doesn't have to remember where it ended, and so on. So the database choice and design is also important. This affects scalability, especially focusing on SQL databases versus NoSQL database debate. Some databases, which especially relational, where you have to have a schema. If a schema is already predetermined, it's difficult to change, especially once data is already added to the database. It will be difficult to change the schema. So in that case, you can't scale a database component under those circumstances. So your choice becomes very important. Your choice of what databases. We now have schema-less databases, and of course the relational database is always schema-based. Right. In consideration 2 relates to reliability and availability. When we talk of reliability, we are talking of the probability that a cloud application will perform the intended functions under certain stated conditions for a specified amount of time. In other words, you can rely on it to perform when you need it, and for the duration that you need it, rather than, of course, all these elements of this definition are important. Whereas in availability, we are talking of the probability that the cloud application will perform a specified function under certain conditions at a prescribed time. So it will have to be available at a prescribed time. The difference, of course, not the difference in the definitions. With reliability, it includes an element of duration. In other words, it doesn't have to. If you need it for an hour, you want it to run smoothly for the entire task. Whereas availability is at a prescribed time only. Right. There are considerations that you may take into account when designing an application that ensures that these two are achieved: reliability and availability. The first one is you don't want a single point of failure in your architecture. Once you have a single point of failure, it brings down the entire system. So you want to avoid that. If you have a single point of failure, then you can't guarantee reliability and availability. Secondly, you want to trigger automated actions on failures. So you need to trigger automated failures. Of course, the cloud can give you that capability. Then third, make sure you build in what is referred to as graceful degradation. Where some components remain available during a failure. In other words, certain parts of a system can fail, but not the entire system. So which basically means it is possible to then fix a component without bringing down the entire system. Then lastly, or rather, the fourth one is logging, which can help you with diagnosis, and most clouds provide logging facilities. These are some of the things that you will cover in the Amazon part of the course. The logging, of course, replication is important. This is where you look at data, and if you produce redundant copies, in other words, you have multiple copies of data that allow your application to function during a failure. In other words, there are alternatives. You create copies of data. You make sure that you don't store it in one location, and so on, to make sure that it doesn't work. Now let's look at consideration number 3, security. Of course, for organizations to adopt the cloud, they have to feel that their data is secure, or their organizational assets are secure, digital assets are secure. So this is required due to also the nature of cloud environments. As you already know, when an organization adopts a cloud, the cloud itself is not being maintained by that organization. It's being outsourced. So the issue of security becomes paramount, because most organizations that is outside their control. So you therefore need to build your applications with security in mind, and choose a cloud infrastructure that also guarantees security, right? It might be important for you to consider quite a number of things. You can see we have quite a number of these. You need to look at data at rest that is in storage, which is data at rest. Make sure it's secure. You also have data that is in motion, that is being transmitted from point A to point B. You want that to be secure as well. And then, of course, make sure that the people who have access, you have authentication. In other words, each person can prove their own identity, and then they have access to what they are trying to access. That's authorization. So authentication and authorization usually go together, because authentication allows access, and then, or rather, authorization controls access, whereas authentication controls the identity of an individual. So identity and access management are important. These two, identity and access management, are related to authorization and authentication. So also key management becomes important, which is also linked to the above two. Then data integrity is also important, as well as auditing. So all these are the entire aspects of security, IT security, are supposed to be considered when developing cloud applications. Indeed, even the AWS is centered around security. So there is no application that you can develop that is not based on the notion of security, where authentication, authorization, identity and access management, and keys are involved. They are always involved, and most cloud applications will force your applications to adhere to some of at least the basic minimum. Of course, you may need to be required to do other things as well. The fourth consideration is maintenance and upgrade. In other words, cloud applications usually start with a core set of working features. After that, you have some increments of additional features. Of course, you can compare this to some of the applications that you have already been using, whether they are mobile apps. Each time you make an update, sometimes you get a new feature. You have often seen even Gmail, we have seen it being changed while we use it. I think this also applies to your mobile apps. You see new extra features being changed incrementally over time. So for this reason, you should design your cloud application in such a way that it is easy to maintain, it is easy to upgrade without disrupting users. So some of the things that you can do is that you specifically aim for low maintenance and upgrade costs, and also use loosely coupled components. As I have said, if components are loosely coupled, it means they are not, you can change one without affecting the other. That allows low upgrade and maintenance costs. It is easy to change and test components. Also logging and triggering automated actions, which also lowers maintenance costs. These are some of the things that could be the aim, your aim as an engineer, as a software engineer for the cloud. The fifth consideration, which is also the last, relates to performance. This consideration is that it's very central actually to most cloud applications. As we have pointed out from the beginning, cloud applications are accessible basically from anywhere in the world, which means performance is a key issue, right? For example, cloud apps with database read intensive workloads benefit from read replication and caching approaches. In other words, you could copy the data and put it in an environment which is optimized for reading to increase the speed. So those are some of the things that there are a lot of tools that are provided to you to ensure high levels of performance. And sometimes companies like Amazon, they go a long way to make sure that you can actually use these tools for replication and caching. For instance, Amazon offers a service which is called CloudFront. What the purpose of CloudFront is to bring some of the data near the users to increase speed and performance of applications. And then, of course, you also need to introduce metrics for performance evaluation, which look at things like response time, throughput, and many other parametrics. So metric for performance, these would be tools that are also given to you within the cloud environment so that you can measure performance and react and do something about poor performance in your applications, because this is key to a lot of cloud applications. Now in section 3 we go over some of the architectures that can be used as templates when you are developing cloud applications. Of course, we assume, you should always assume that such reference architectures have placed all these 5 considerations into account, and they can be used as templates to build your own cloud applications.